Hello, welcome to a video about snow cover, which is your 8th topic on your research project for climate change. I've covered all the topics. This is the last video. So snow cover, what I'm going to do is I'm going to cover each of these individual sources for you. Okay, and my goal here is to go through each source so that you kind of understand it a little bit better. And I kind of want you to kind of hear my perspective and kind of see what I'm thinking and how I process this stuff, because I think it'll help you kind of form your ideas and opinions and kind of think about this. So let's jump right into it here. We're going to jump into spring snow cover with the climate.gov, which is its first site here. So this is going to be showing you a lot of pictures and images of snow cover in the springtime. One of the things that I'm asking you to do is tell me how do we know this information? So like, how did we come to measure this and stuff like that? So we're going to have to kind of figure out how do they measure snow cover. And let's see if we can find that out from here. If it doesn't tell us in the source, I'm just going to straight up tell you how it happens. So here we go. So this is measured snow cover looks like, oh boy, look at all this measurement. Okay, so here we have 75 through 79 and then 2015 to 2019. So it says here records from the last 5 decades show that on average, spring snow is disappearing earlier in the year than it did in the past, with most rapid declines in snow-covered area occurring in June. So June is like midsummer, right? And we're going to lose a lot of snow cover in June. So if we lived in places like in the mountains where there was more snow long-term, we would see this happening. But since we don't really, it's going to be kind of, this is going to kind of just be us talking about the snow in other places in the world. So here's where a lot of the snow is that we're measuring here. And you can see this is the northwestern part of Canada and the United States, the Rocky Mountains down here, and then up through Alaska and out into Russia. So this is kind of snow in the northern regions of the world. And you'll see here that blue is like a high value in terms of percentage. So like 100% snow cover would have been like what we classified the snow cover in the 70s. And now you can see that most years, with a couple of anomalies here in these heavier snow winters of 17 and 18, that our snow on average is drastically different, and in some places completely not there in June. So we're measuring snow cover in June. Okay, so how do they do that? They're figuring out how much snow's in this area. Some of this data is coming from satellite images, and some of this data is actually coming from measurements. So we actually go out and we put down these snow measurement stations in these snowy regions that actually measure like the mass of the snow and how much snow there is and things like that. So there's some physical measurements that are happening on Earth and some satellite data. So that's going to help you answer your how question. So that's what this is showing. You can see that on average we have less snow in June now, which means that the snow is mostly gone by that point. And then let's go down here. This is a graph showing the March to April snow cover anomaly. So anomaly is like the difference from the average. So 0 would be the average amount. And they probably created this average. Yeah, so they created an average using the amount of snow cover measured from 1981 to 2010. And then they just graphed all the data from those years or years before. So this looks like it starts in 65, probably. 60, what year is that? So like 66 or 67, actually. And it goes all the way until last year, 2019. Measuring the snow cover. So you can see that red is when we have significantly less snow, and then blue is when we have more. And you can see that we've had as much as up to 4 million square kilometers more snow and up to almost 3 million square kilometers less snow. But generally speaking, starting in the late 80s, early 90s, we mostly have years that are under in snowfall. But if you look back up here, right, these two graphs are showing that there's actually some additional snowfall in 17 and 18, and you'll see the same thing here on this graph. The anomaly is actually higher, but most of the time on average we're seeing less snow. Okay, so this actually does tell you how you measure snow extent. So a lot of this is using satellites. Okay, so starting in the 60s we started doing this with satellites, but we've also been using things like ground observations, using precipitation gauges, so like your water gauges and snow gauges, weather stations, and pressure sensitive pillows. They actually go out and put these plates on the ground that as it snows on top, they're measuring how much snow is there and how long and things like that. It's pretty cool. Took a whole class about it in college, so if you're interested in that, it's out there for you. Then it explains some impacts, why losing snow earlier is bad and things like that. That's the first source. Okay, so this is a pretty good image. You probably don't want to use the entire thing. So if you're going to take a screenshot of it or something, just pick like a couple of them to show, like here's what it looked like this and here's what it looked like now. If you want to use the whole thing, you could, but make sure you put this key down here in there so that you can explain it to people, and make sure you cite your source if you're going to use it. Okay, here we go. Second source. What does snow cover have to do with climate? So, well, in the winter, we've got snow, right? And this article's gonna kind of explain like how much of the world is covered in snow and when the snow is there and all this stuff. So while snow cover affects climate, change in climate also affects snow cover. Overall, warmer temperatures are shortening the amount of time snow is on the ground in the northern hemisphere. Recent temperature increases in the Arctic North Pole have led to decreased snow and ice cover in many areas during parts of the year. They've also led to earlier melting of snow cover, which is changing when and how water is available in some rivers and reservoirs, as well as lengthening the growing season. So it's changing like our agriculture, it's changing habitats. There's a lot of changes happening because of this climate change, but snowfall is part of it, right? So like imagine you are an animal that lives in the snow and you have to migrate to where the snow is, right? So maybe like in the harsh winter when it's really cold in the Arctic, you can come down a little bit into northern Canada, northern Russia, and you can live and everything's fine because you're white and you need to live in the snow. And that's what you do. That's what your species does. But like if the snow's gone and you're still down there, you're going to get eaten because you're white and you stand out against the grass, right? We talked about that when we were talking about natural selection. So it actually is kind of forcing some of our evolutionary processes to happen, and species are not able to recover or adapt. And so then they like in the time that they're given versus how the climate is changing, and then those species they go extinct, they die, and they're endangered, right? So some of you guys are probably thinking like, oh no, the snow and ice is melting. That's like where we got the sad, hungry polar bears sitting on like looking lonely on the icebergs and stuff. Yeah, it's related to that as well. So here we go. Here's another graph. This one's really nice. This kind of shows that spring snow cover anomaly, March to April, the change in snow cover. And this, someone drew a trend line on it just to kind of help you see. And this is old data. That other image, this one is actually more updated. It has like the last few years on it. This graph only goes until like 2013, but you can see it's sort of trending down, right? There's a couple of things that make you go, huh? Is it actually? Because like look at this big spike for like 5 years, right? But generally speaking, we're kind of going down. Okay, so that's kind of something that you could show to help people kind of understand that snow cover is generally less, or going away faster in the spring is probably better. Not like it's snowing less, it's not snowing less really. It's just there's less snow in the spring and in the summer because it melts faster. Okay, so then here's another explanation of that. So talking about spring snow cover and what that means and what it does and how it affects the things that are living there. Okay, so think about that. And it's going to talk about this thing called snow water equivalent. That's like how much water is packed up in the snow, really. So like that's a measurement that we do when we're measuring with satellites and with our the snow pillows. They're measuring the snow water equivalent. It's all part of this like big model that helps us kind of measure how much snow and how much water there is going around and cycling on the Earth. So that's your third source. And here we go. Arctic snow cover shows sharp decline. Earlier spring could spell trouble for permafrost. Have you heard of this permafrost stuff? It exists in some of your specific biomes. It basically means like the top surface of the ground is permanently or all the time frozen. If that permafrost is melting, things are going to happen that are different. It's going to change the area, and it actually is going to produce some greenhouse gases. Fun fact. So you can read this article and see all about it. This article's got a lot of like jargony, fancy schmancy, sciencey people words because it's from Nature. Nature is like the best journal for science out there. It's like the big one. If you get published in Nature, you're like a real person. Like Hannah Hogue, she's probably a big deal now, right? Because she's got this nice article here. So, but anyway, so here we go. This is going to tell us a little bit more about it, right? So like we're seeing that the snow extent is lowering. It has to do some with like sunlight being reflected away and things like that. So like snow actually reflects sunlight, which is useful because it keeps some of that heat from getting absorbed by the ground and by the things that are there. So if you're reflecting sunlight, it's actually helping keep the Earth cool. So having snow in places that get lots of sunlight is actually good for keeping the Earth cooler. And if that's gone, we have this increase in warming, which is then going to melt more snow faster, and then it cycles and cycles and cycles, which is awesome, but also really terrifying. So that's what this is all about. And then there's this thing about shrinkage and measuring the amount of snow that's going down. So basically the whole idea of shrinkage is that there's less area covered by this blanket of snow. Okay, so that's like kind of the short version of it. If you want to get into the nitty-gritty details, you can read about it, and you can kind of connect this to the ice, and you can connect it to the temperature rising, and you connect it to the water in the oceans and things like that if you like, for your project. But all these things, all these topics are related. So I just wanted you to kind of see how snow cover fits in. Okay, I hope that helps. If you have questions, let me know.